This is 2.4, first day on 2.4. We're going to factor and solve quadratics. Your assignment for this is going to be to do 1 to 24 on that worksheet. That's not the whole thing, okay? So just 1 to 24 as you saw on the assignment sheet that I just gave you, okay? So on worksheet 2.4. All right, before we start this, we need to do a little review of some things, some skills we're going to need to have. So can you put Roman numeral 1, review? And we're just going to simplify a couple problems, make sure we're good with this. Again, it used to be, if you did the old route, pre-algebra, algebra, geometry, by the time you got to this class, which is theoretically the equivalent of Algebra 2, you would have done this simplifying for 4 years. I think the first time you simplified radicals was last year in Math 2. So it's just really different. We need to practice this a little bit, make sure we're good. If I ask you to simplify the square root of 20, I'm not asking you to approximate it. That's a good skill too, and I think most of you could tell me it's like 4.5-ish, okay? But I'm asking you to simplify it, and what that means is if there's any perfect square factors underneath, you need to pull them out. So do you remember how we did this last year? How you guys did it? How did you do it? What did you do? The factor tree, right? And what were you looking for as you made the factor tree? Pairs, right? Every pair underneath came out as 1. Okay, so factor 20. Give me factor it for me, Jonathan.
10 and 2.
10 and 2, okay. And then 10 we could factor as 5 and 2, right? And you're getting to the prime factorization, so you got 5, 2, and 2. And you're looking for pairs. And so this pair of 2's would come out. It has to have a partner to break out of the radical prison, right? To get out of there, it takes 2 of them to get out as 1. And then the 5 is left under because he doesn't have a friend to break out with. Okay, so 2 would come out and 5 would be left under. Now, I actually liked, I think over here, somebody over here said 5 and 4. I kind of like that factoring because 4 is a perfect square. Another way to approach these is to look at factors that are perfect squares. What's the square root of 4? 2. And then 5 is not a perfect square, so it would stay underneath. That's maybe a faster way to factor these. That's another way you can think about it. So you can do the factor tree. It kind of takes up paper and it's a little bit longer. But if you can think of perfect squares that go into it, that's just another way to do it. Okay, and again, we're working for efficiency, which is speed, but also accuracy. So you got to figure out which method works for you. Can we try this second one, looking for perfect square factors, and then, so practice that a little bit, and then you decide which method you like. Okay, either way is fine, but we're going to try this other. So if I had the square root of 63, what I'm going to look for are factors of 63 that are perfect squares. What goes into 63 that's a perfect square? 9, right? This is 9 times 7. So if you think of this, this is the same as the square root of 9 times 7, which you can break up as root 9 times root 7. What's the square root of 9? 3. So the root 9 comes out as 3, 7 stays under. Can you see that that's the same thing as if I broke up the 9 into 3 and 3, circled that, pulled out the 3, and left the 7 underneath? It's the same math. But if you see this is 9 times 7 and then just take the square root of 9, it's a little bit faster. Okay, one more of these. Let's go root 24. Can you think of a perfect square factor of 24? 4, right? It's 4 times 6. Okay, square root of 4 is? So again, you can almost do this first step, but then the square root of 4 is 2. See, 6 doesn't have a perfect square factor of it. Okay, and again, if you want to finish the whole thing, you'd have 2 2's here that you're going to pull out, but this 2 and 3 would stay underneath. So you'd circle that pair, and then you'd have to multiply that back, and kind of a lot of steps. Okay, if you can think of factoring it with the perfect squares, pull it out that way. Okay, you guys good with that? All right, we're going to go now to solving by factoring. So the first part of this worksheet actually is going to have you just factor, and then the second part is going to have you solve by factoring, as far as what we're doing today. And so we're just going to jump to the solving because we're going to practice the factoring in the solving. This first one is already going to be factored for us. X plus 5 times 2x minus 7 equals 0. That has already been factored. Okay, now you guys, here is the rule. You ready? I really want your focus on this because this is a big concept here. Okay? This is saying this number times this number equals 0. If I multiply two numbers and they equal 0, what does one of those numbers have to be? Has to be 0, right? Isn't that the only way you can get 0 as a product? Is if one of those is zeros? Okay, now, what if these two numbers were multiplied together and it equaled 2? Would one of those numbers have to be 2? Is that the only way you could get 2 by multiplying two numbers together, is if one of them was 2? Or 4, maybe that would be easier. What if this had been set equal to 4 instead? This is saying I'm multiplying two numbers and making them equal 4. Does one of those numbers have to be 4? No, you could get 2 times 2, right? You could have 4 times 1. You could also have 8 times a half. You could have 36 times 1/9 would give you 4. There's an infinite number of possibilities here of what those two numbers could be. But with 0, the only way to get 0 is if one of these is 0. Okay, so the first thing you are always going to want to do on these is make sure it equals 0, not any other number. Because the only way we can use this rule is if the product equals 0. We're using the 0 product rule, which says one of these has to be 0. And so we just set each of these equal to 0. Take x plus 5, set it equal to 0. Take 2x minus 7, set it equal to 0. You did this last year, right? This isn't new. Okay, but the important thing is it has to be 0. All right, subtract 5 here, and one solution would be x equals negative 5. Add 7, and then divide by 2, and the other solution would be 7/2. That's fine. You can circle those answers. That's beautiful. On the multiple choice section of this test, it's going to write the answer like this. That's a way of expressing it as well. It's saying just those two numbers are the solution. Okay, so either way, whichever, I don't care how you want to express that. All right, on this next one, 4x squared minus x equals 5. 4x squared minus x equals 5. Okay. I don't want it to ever equal 5. I don't want it to ever equal anything except 0. So I'm going to subtract that 5 over to the other side and make it equal 0. Okay, and then we're going to try to factor this. And we started with one that was kind of tough, but we did a factoring review at the beginning of this unit, the 2.0 worksheet. What's difficult about this one is it's these first two terms, right, have to multiply together to give me 4x squared. I have a couple options. What are some factors of 4? I could have 4 and 1, or I could have 2 and 2, right? And then, of course, I'm going to throw an x in there. This is the trial and error. Now, 5 comes from the last two terms being multiplied together. There's only one option for that, right? I mean, 1 and 5. So I'm actually going to put those guys in first. I'm going to put the 1 and the 5 in. And if it's negative 5, one has to be positive and one has to be negative. I'm going to figure that out in a minute. I usually like to start with the 2 and 2 myself. Okay, so let's do 2x and 2x, and it's trial and error. And what I like to do is say that the little happy face and the big happy face, when you add them together, have to add up to this middle number. So here's the little happy face. It's the inner. And then we're going to multiply the outer. That's the big happy face. Okay? So let's see, if I multiply these together, I'd get 2x. Multiply 2x and 5 together, I get 10x. Now I'm trying to come up with negative 1x. Any way to make 2x and 10x equal negative 1? No. Okay, so I'm thinking that 2 and 2 is not a good option. Let's try 4 and 1. Where do you want to put the 4? Where do you want to put the 1? Where do you think the 4, do you think we'd want to multiply the 4 to the 5?
No.
Like, would we want it here to get 20x? And then the 1 here? I'm thinking let's put the 4 over here and the 1 here. So you're working with the factors of 4 and then combining them with the factors of 5 is a little tricky. Okay, so multiply these, I get 4x, right? Multiply the outer together, I'm multiplying those, I'm getting 5. Okay, I like that. I'm trying to get negative 1x. I could do that, right? As long as the 5x was negative. Then when I added those, the idea is you add those, do they give you negative 1x? Yes, they do. Okay, so if I want the 5x to be negative, then I need this to be minus here, right? I want the 4x to be positive, I need that to be plus. That's the trial and error method. Okay, there's other ways of doing it, but that is one method. Generally speaking, it can be a fast way to do it. All right, then once we've got that, set each of these equal to 0. So x plus 1 is 0, 4x minus 5 equals 0. I can only do this with 0. Can't do this with any other number. Okay. Subtract the 1. One solution is negative 1. Add the 5. I'd have 4x equals 5, and then divide by 4, and I'd have x equals 5/4. And so possibly the solution could be written with these little braces. And those would be the two answers that I could plug into the original equation and it would be true. Okay? Let's try another one. Number 3. X times 2x minus 3 equals 5. This actually is factored on the left-hand side, but the problem is this over here is not 0. If this was 0, I could just set each of those equal to 0, but I cannot do that with 5. Okay, so what do you think we're going to have to do first on this one? Distribute. Yeah, so distribute this. So x times 2x is 2x squared, right? And then minus 3x equals 5. And then subtract the 5 over. Make it equal 0. When you're solving by factoring, you want to get 0 on one side. Okay? Then we're going to try to factor this guy. So let's do him again with trial and error. This one, the options, there's not that many. Again, the idea is this first term, that 2x squared we got by multiplying these two guys together. The first we get multiply those. There's only one way to do that. That's with a 2x and a 1x, right? The only factors of 2 are 2 and 1. So I'm going to put a 2x here and a 1x here. Okay? And then the last term, that negative 5 we got by multiplying these two together. My only options are 1 and 5, right? But where I put them could change. Okay, so what if I put the 1 here and the 5 here? Could I come up with a negative 3x when I added the inner happy face and the outer happy face? Okay, so if I multiply these together, I'd get a 1x. Multiply these together, I get a 10x. Any way to get that to equal negative 3? Yeah. Okay, so let's switch the 1 and the 5. Trade where they are. Put the 5 here and the 1 here. So then when I multiply the inner, I'd have a 5x, right? And when I multiply the outer, I'd get a 2x. Okay, now we're trying to get negative 3x. I think we can do it. How? The idea is I want to add these two guys together to get negative 3x. What would need to happen? You got it? The 5 needs to be negative, right? So then negative 5x plus 2x, yeah, that would give me negative 3x. Okay, so to get the 5 negative, I need to make that negative, and that means I want the 1 to be positive. And wouldn't that give me negative 5? Yeah, I needed 1 positive, 1 negative. Okay, once you have that factored, then set them each equal to 0. 2x minus 5 equals 0. X plus 1 equals 0 using the 0 product rule. Add the 5. Divide by 2. And 5/2 is one of the solutions. Subtract the 1. Negative 1 is the other. And again, if you see the answer, it's going to be expressed like this. But as I said, I'm good with you guys just circling that, saying those are the two answers. Okay, let's try another one of these. The quantity x plus 2 times the quantity x plus 5 equals negative 2. Okay. This is all factored, but there's a problem. What's the problem? They don't equal 0. Okay. So since it doesn't equal 0, and just adding the 2 over, eventually I'm going to add the 2 over, but that's not going to do it for me. What are we going to have to do? Yeah, the double distribute thing, this is the Parrot's Beak. Have I shown you guys that? I did, right? Did I show you? Yeah, I showed you the Parrot's Beak. This is where you do first, right? Foil, you do the first together, that would be x squared. Then you do the outer. Then you do the inner. And then you do the last. Right? First, outer, inner, last. Combine the 5x and the 2x to get 7x. And then can we add the 2 over and make this plus 12? Is that okay? Set it equal to 0. So combine the 10 and then add the 2 over, make it positive 12. Okay, then we're going to try to factor this, which actually I like this kind. If there's no leading coefficient, the trial and error is a lot easier, right? Because your first term has to just be x and x. Then it's 2 factors of positive 12 that add to positive 7. You think of 2 factors of 12 that add to 7, Nick? 4 and 3. Okay, and since everything was positive, these are both going to be positive as well, right? Positive 4x, positive 3x. Yeah, that gives me positive 7x. That's beautiful. Okay, and then I can set each of these equal to 0 using the 0 product rule. And so the two solutions are negative 4 and negative 3. What's that? Usually, yeah, I always do. All right, 1, I totally have this. 2, I mostly have it. 3, I mostly don't. 4, I really don't. Can you tell me where you're at, please? I think we did a great job in that. Awesome. Very good.